So now I want to go over solubility. So solubility, first of all, when we say when chemists talk about the solubility, they're talking about the maximum amount of a solute that can dissolve in a specific amount of solvent, and usually they're talking about 100 grams of solvent. So when we talk about solubility, we will typically be talking about water. So the grams of solute, it could be either solid or gas, dissolved in 100 grams of water. So, a solubility curve actually describes the solubility of different solutes in 100 grams of water. So, you guys should have a solubility curve for those of you in class. And for those of you online, this will be under classwork under your reference materials. But the solubility is on the y axis, and this again is the grams of your solute in 100 grams of water, and the temperature is on the x-axis. The solubility curve that you have describes four particular solutes. You have silver nitrate, you have potassium bromide, potassium dichromate, and sodium chloride. Other solubility curves will have other solutes described on them, but these are the four in yours. So I want to go over, first of all, how you read solubility curves, and then we're going to go over some different types of problems. Before we go over how to read solubility curves, I want to describe first three different types of solutions. So when you're dissolving something, um, at the beginning, for example, if you're making sweet iced tea, when you start adding sugar to your iced tea, at the beginning, you're going to have an unsaturated solution. So you put some sugar into the iced tea, and what you have here is if you were to add more sugar, and that's what's shown in this picture here, it would continue to go into solution because more can be dissolved. So an unsaturated solution just has less solute than can be dissolved at a given temperature. If you were very patient, eventually, if you added enough sugar, you would get to the point where you have a saturated solution. This means that you cannot dissolve any more solute at a given temperature. So if you add more solute, and that's what's happening in this picture here, the solute you're adding is just going to fall to the bottom of the solution. It will not go in solution. Now, if you were to heat up that sweet iced tea to a higher temperature and add a ton of sugar to it, what you would find is that at that higher temperature, remember for solids at higher temperatures, more you will be able to get more in solution. It's going to be more soluble. So at the higher temperature, you can get a lot of sugar in solution. And if you're very, very patient and very slowly cool that solution down, you're going to get a supersaturated solution. This is very unstable. This actually holds more solute than would normally dissolve at a given temperature. And if someone were to come along and kind of hit that solution, or maybe some dust or maybe another piece of sugar were to fall into that solution, what you would notice is that crystals would start to form almost instantaneously in that solution. And that's what this is that's what's happening here. So just to give you a better picture of a supersaturated solution, I want to show you guys a video of a supersaturated solution. Okay, so in this video, what's happening here is this is a supersaturated solution of sodium acetate. So this person is pouring it out into a petri dish. And there was a small crystal of sodium acetate on the petri dish. So as they poured it out in the petri dish, the solution immediately started crystallizing. And this is not sped up, this is in real time. It happens very rapidly. Now, if you look at this, what you're going to notice is that this solution is completely solid now. It's completely crystallized. There really isn't any liquid left. And now they're going to add more of that supersaturated solution to the surface of those crystals. And what you're going to see is as they add it, what they're adding immediately starts crystallizing on the surface of the already present crystal, is making a tower. Okay, so now they're adding more of the solution into to this to there, makes the tower higher. Pretty cool. But actually, this is really hot. When this stuff starts crystallizing, it gives off a lot of heat. And if you think about your reusable hot packs, when you hit it, this is what's inside of those reusable hot packs. When you hit it, it creates like a little defect there, starts crystallizing around it, and then heats up. And then here they took the solution, added a crystal to it, so you can see how rapidly it crystallizes. Okay, so that's a supersaturated solution. Okay, so now I want to go over how to read these solubility curves. So when you look at a particular point on one of these curves on your graph, this is describing a saturated solution at that particular temperature. So this point here in red, this says that it's 70 degrees Celsius. Remember, temperature's on the x-axis. If we have 100 grams of water, so all of these are within 100 grams of water. If we have 100 grams of water, we have about 90 grams of potassium bromide. So these grams are describing your solute. 90 grams of potassium bromide in 100 grams of water at 70 degrees Celsius. If we have a point that lies above the curve, so here we have this red point here, we're still at 70 degrees Celsius, but 70 degrees Celsius, if we have 100 grams of potassium bromide in 100 grams of water, this is actually a supersaturated solution. So anything above these curves for that particular solute will be describing a supersaturated solution. What we can also tell here is if we were to heat this solution up to about 90 degrees Celsius, it would become a saturated solution. So we would say that by heating at 20 degrees, we can make it saturated. We also know that if 10 grams of material, so there's actually, but if you look at this point here and that point on the curve, there's a difference about 10 grams. The 10 grams of 10 grams of your solute would precipitate out, and then you would have a saturated solution. Any point below the curve is an unsaturated solution. So here we still have potassium bromide. At 40 degrees, if we had 60 grams of potassium bromide in 100 grams of water, that would be unsaturated. If we go keep the amount the same but change the temperature, we would see to make it saturated, we would have to cool it down about 27 degrees Celsius in order that now 60 grams would be fully dissolved, would be saturated in 100 grams of water. We also know to make it saturated, we would, by keeping the temperature the same, we would have to heat it up. We would have to add about 11 grams of solute to bring that point up to where it would be on the curve So now we would have maybe about 71 grams of potassium bromide dissolved in 100 grams of water at 40 degrees by adding those 11 grams to our 60 grams of solute. So now I want to go over a few different types of problems on your solubility curve worksheet to just show you the thought process. So first of all, when you get a question like this, which soluble is least soluble, or if it were to say most soluble in water at a particular temperature, is talking about the least number of grams at 20 degrees Celsius. So for that, you would have to look at your graph, and you would go up and then just see which one, comparing this at the same temperature, which solute had fewest number of grams. And we're talking about on these curves at 20 degrees for that. Okay, the next type of problem you will see is a problem where they don't give you 100 grams of water. So I want to look at this one here for number 6. So this is talking about sodium chloride in 50 grams of water at 90 degrees Celsius. So all of these things on your graph are in 100 grams of water. But if you don't have 100 grams of water, sometimes you have to do a proportion, or you can just simply think of a recipe, maybe doubling your recipe or tripling your recipe, or maybe halving it or whatever. So what we need to do is look at 90 degrees and see how much sodium chloride goes into 100 grams of water. So we're going to go up 90, and we can see it in 100 grams of water. It's this is going to vary from student to student. So I would say maybe about 32 grams in 100 grams of water at 90 degrees. So what we have to imagine is, what if we only have 50 grams of water? So the denominator will be our grams solvent, and numerator will be grams of solute. You notice your temperature does not go in this proportion, so do not put in that 90 degrees in your proportion. So now we solve for x. So we would get, when we solve for this, we would get about 16 grams of sodium chloride in 50 grams of water. Now, this answer will vary from student to student depending on their estimate from that curve. So you're going to have to do something similar for number 8. There you have 300 grams of water, so you're going to have to, again, separate proportion, or maybe just think about tripling, or whatever with your recipe. Now, when you see a question like this, which one shows the least change in solubility, you're going to look at the slope of your curve to see which one has the most dramatic slope or which one has the least amount of slope, to figure out that. And when you have a question like this, where asking how much will precipitate, like for number 10, what you're going to have to do is you're going to have to go up to your curve at 70 degrees Celsius. And so let's look at this. So we have 70 degrees Celsius, and we're going to see how much potassium dichromate goes into solution. So at 70 degrees Celsius, we have about 60 grams of potassium dichromate. Now, what it's saying is, if we cool it down to 25 degrees Celsius, so now we're going to cool it down, so we're just changing the temperature. We're not changing the amount, so we're cooling it down to about 25 degrees Celsius. We get a point right here. To figure out how much will precipitate, we're going to have to take that difference between that point and the point on our curve to see how much will precipitate. So that's how you would do a problem like that. And You would have to do something similar with number 15. So when you do this, you're also going to have to take a difference. And this one's asking about how much more can be dissolved. So you should get a point that's below the curve, and you would see how much you would have to add to bring it up to the curve. Okay, so these are just some different strategies you can use. I want you to try all these and see if you have any questions, and we will go over these next class so you could check your answers. So good luck.